Hello, welcome to today's lecture where we will explore the electromagnetic radiation. What is its significance in remote sensing? So, as we have already discussed in chapter 1, that there are five elements uh, remote sensing. These five elements are energy source, radiation, energy interaction with target, and the recording of energy by the sensor. So, in chapter 2, we are going to cover these four parts here. Let's begin with chapter 2. So, sorry, electromagnetic radiation. This radiation is important for remote sensing. Without this radiation, we cannot do uh, remote sensing, I mean the passive remote sensing. And uh, there are two characteristics of this radiation. First is wavelength, and second is frequency. But in remote sensing, whenever we go for data collection like this is the remote sensing data, and we are going to collect this data here, and we look at the bands, then we see the wavelength. So wavelength is very important to understand uh, because remote sensing data comes into different bands, and these bands are defined based on the wavelength. So this is the significance of wavelength here. Not all energy is useful in remote sensing, but some part of energy is very useful. And this energy, uh, I mean, the wavelength, the word length is measured in meters, nanometers, micrometers, or we can use centimeters also. So, radiation, important property is wavelength, which is defined based on the wavelength. What is the length of the wave? Here, this is the visible energy. In this visible energy, you can see that it moves in the form of waves. The blue energy, you can see the wavelength is shorter, and the red energy wavelength is little larger. So this is the wavelength here. Now we see the electromagnetic spectrum. The highlighted part is the key part which you should keep in your mind, electromagnetic spectrum. We can divide this spectrum into the visible spectrum, where the blue, green, and red are the primary colors of wavelength, the visible spectrum. Blue, green, and red. Now you can see here this is the blue because here Landsat 8 data is giving us two bands in the blue part. Then this is green and this is red. Okay. So if I say band number 4, so band number 4 is the red band. Band number 3 is green band. And band number 1 and 2 are the blue. This is ultra blue and this is blue. So this is the visible spectrum. And after the visible spectrum is the infrared region, which is very, very important for remote sensing. And we cannot, uh, our sensors, I mean the human eyes, cannot detect the infrared region. But the human-made satellites, the detectors can detect the infrared energy. So this is the reason why the remote sensing makes you very powerful. So infrared region further, uh, it may be divided into two categories. One is reflected infrared, another is thermal infrared. The reflected infrared is 0.723 micrometer, while thermal infrared is quite different than visible or reflected infrared, because the radiation that is emitted from the Earth's surface in the form of heat, uh, this is the thermal infrared, okay, reflected detection of this heat. So infrared part divided into two, reflected and emitted. As you can see here, band number 5 is near infrared, 6 is infrared 1, short wave infrared 1, and this is short wave infrared 2. You can look at the wavelengths here. And now we are talking about the thermal infrared here. Thermal infrared is mm, is not, I think, given here. There is a thermal infrared that is band number 10 and 11, which can be uh, used to analyze the land surface temperature. Bed number 10, 11. Let's move ahead. Energy interaction with Earth's surface. Energy interactions. Here, what does it mean? Here, the energy interaction with the Earth's surface. There are different bands, and each bands behave differently. For instance, if you see here, this is Landsat 9, blue band. This is water here. This is a lake. Let me show you. This is the lake here. And if you see the blue band, the water area, the reflection is more. That's why it's lighter here. But on the other hand, if I take the near infrared band, then the reflection will be very low because water absorb the near infrared energy. So wherever the lower values are there, you can say that water is there in near infrared. So different bands behave differently at different types of the land cover. Now have a look at the vegetation. In high vegetation areas, the near infrared energy reflects more. Wherever there is a high vegetation, the near infrared energy will be reflected more. So for vegetation and water analysis, the near infrared bands plays a very significant role. Uh, okay, so energy interaction with Earth's surface. There is absorption, there is a transmission and reflection. So what energy is used in remote sensing? That is the reflected energy, which is being reflected from the surface of the Earth, because this is the energy which is being detected by the detector. So how leaf or green vegetation behaves? The green vegetation, the near infrared reflectance, with the help of this near infrared reflectance, we can determine the health of the vegetation. If near infrared is higher, vegetation is healthy. If near infrared is giving you less values, then the vegetation is not healthy. What about water? The infrared energy is absorbed more by water. So wherever you see the values are low in this band, for instance, I want to know where water is. I can use near infrared, I can use short wave infrared, I can use short wave infrared too. All this energy is will be absorbed wherever water will be there. This energy is very useful to detect the water as well as vegetation health. And now, if you see the surface of the earth, even the soil has water, soil moisture. So, soil moisture can also be studied with the help of near infrared and short wave infrared bands. Similarly, there is a water content in the vegetation. So, for that water content, the near infrared, special, yeah, NIR band as well as short wave infrared bands are very useful. These two. So the energy comes in the form of bands, that is blue, green, red, near infrared, short wave 1, short wave 2. And now you may be thinking that how this true color image is there. When we make the combination of three bands, that is red, green, and blue, then the true color image will be there. So let's see the combination of true color. So we are using red, green, blue energy. So this is the true color image here, which is the median of December to February when there is no cloud. But on the other hand, if I take the June to August imagery, the whole area will be cloudy. You see, there are clouds which are masked. Though the values are maximum here, let's see median. Or if we take only the time like June to June, or we can say the last year, because here median values, the median values uh, removes the outlier, the darker areas as well as the clouds also. Yes, this is true color. But question is this, that when the near infrared or short wave infrared is very important to study the vegetation water, but here there is no short wave infrared or near infrared band. So we cannot visualize, or we cannot study better with the help of this two color image. That's why we take the false color combination, where the near infrared bands is given to the red, and near infrared is reflected more from the vegetation. So all red areas will be a representing the vegetation. The time band is very low. Yes, this is March. Better to take the whole entire year. Okay, yeah, this is the entire year, 24, 25. So wherever you see the red color will indicate the healthy vegetation. Okay. And now this image, you can do classification, you can extract the healthy vegetation. There are classification techniques which can be used to classify those areas where this red vegetation is there. And you can say that how much area is being covered by the dense vegetation, or how much area is being covered by uh, the the land cover where there is no vegetation. So this is the significance here, how the energy is interacting with the green vegetation and the water. We can look at the single bands as well as we can make the combinations. And now have a look at the satellite image characteristics. When you look at the data, Landsat data, and at present there is Landsat 9, it is Landsat 8 also, but here just for demonstration, started from 21st October to present. Let's see. And now come to the image characteristics. Because when you go to download your data, there are certain characteristics which you have to keep in your mind uh, before data collection, or uh, if you are uh, reviewing, or if you are doing some work, and then you see that okay, this is the report of this remote sensing analysis, then they will give you the data source, and then the data characteristics are important to know that this is the data used, and what are the characteristics of that data. For instance, if the reports is based on Landsat data, then this data, the characteristics, well, first let's see the sensors. Satellite images, there are two sensors: passive sensor, active sensors. Passive sensor depends on the sunlight. Here, whatever the example and uh, demonstration, this is based on the passive remote sensing. Another is active sensors. Active sensors have their own source of energy, and here they use longer wavelength. The wavelength may be in centimeters and meters. So when there is a longer wavelength, it penetrates the clouds and it is not dependent on sun. So when there are clouds, no problem. When there is no sunlight, no problem. At night also it works. But active sensors cannot give you the biophysical characteristics of the vegetation, like uh, like chlorophyll content, something. It's difficult. Of course, we can estimate the biomass there. So the difference is passive, dependent on sunlight. Active does not depend on sunlight. They have their own energy, and this energy is used for uh, vegetation analysis or some kind of water uh, areas, the flood, the urban areas, like that. So here we are talking the passive sensors. Here satellite uh, characteristics, orbit and swath. Based on orbit, uh, there are geostationary satellite and sun synchronous. Geostationary satellites are commonly used for communication purpose. These satellites remain and focus at certain part of the surface of the earth, and these satellites are placed at a very high altitude, and these are called geostationary orbits. They also the, I mean the satellites revolve the speed which matches the rotation of the earth, so they seems stationary, right? While sun synchronous, basically their path is north to south, or it may be south to north also. So this is the difference of orbit. And then swath. Swath is that what portion of the earth's surface is being imagined. That is the swath. Maybe it is given here. Swath cannot be, I think. Yeah, it's not, I think, given here. It varies. Swath may be, for instance, if there is a satellite, this is this Earth here, and let's say that this is the okay, satellite's movement. This is what? This is the swath here, this part. This part. Maybe 20 kilometer, maybe 100 kilometer, maybe 500 kilometer. This is the swath. As the satellite is altitude is more, swath will be more. Altitude is less, close to surface of the earth, the swath will be lower. And then we move to the satellite image characteristics. What are the image characteristics? There are four characteristics which are important to know. One, I mean, these are the four characteristics. Very important to know. Spectral bands means how many bands satellite is giving you. This is Landsat 8, and there are 7 bands here, and another 3 bands are more, 3 or 4 bands are more. Yeah, here is band number 10. Yes, this is band number 10. There is band number 11 also. Okay, so here you see as many bands. But if I see the sentinel band, sentinel, let's say multispectral, this is sentinel 2, passive based on passive remote sensing. So number of bands you see here, 12 bands are given. Okay, it may have even, I think, more than 12. Some of the bands are not given. So spectral resolution is that the spectral means uh, how many bands you are giving, the wavelength, how many wavelengths, how many bands you are using. Okay, if you are using more bands, means your spectral resolution is higher. You are giving different bands because some specific band width give you some specific information which is very significant to study some kind of the rock type or maybe some specific type of vegetation or the soil type or something else. So as number of bands increases, there will be more clarity uh, uh, in differentiating the different types of uh, land covers. Now the second is spatial resolution. Spatial resolution is significant when we see here, if we take any image, let's say here, take the any band, and when you zoom in at the end, there is a pixel here. What is the length and width of this pixel? This is known as the spatial resolution. If it will be less, your image will be more clear. The pixel size will be less, there will be more clarity, and that will be known as high resolution. But if the resolution, I mean the length and width of the pixel increases, the resolution will be down and there will be no much clarity in the image. So this is Landsat 9. For instance, if I take the modest data here, you see 250 meter. This is a spatial resolution. This is 30 meter. This is a spatial resolution. So this is Landsat 9 now. If I compare with Landsat this Terra, and you see the resolution is this is not, it will not be clear. Okay, so both are important. If you are studying the whole country, then you can study with the help of modest data very well. And if you are studying some smaller area, some the district, then you can use the Landsat data. And if you are studying some even smaller ward, then you can use the Sentinel data. Its resolution is 10 meter. So if I see the Sentinel data, its resolution it will be higher. You see, it's more clear. So this is the spatial resolution. What is temporal resolution? Temporal resolution is what is the revisit time of the satellite for the same specific area. How many days it will take? If it takes, like, if you see here, 5 days. So if repetitive time or revisit time is 5 days of sentinel data, on the other hand, if I see the Landsat data, the revisit time is 16 days. So 5 days is better than 16 days, because each 5 days satellite will pass through from a place and you can get more information, especially if you are studying the flood, impact of flood. So this 16 days may not be a good choice. You can choose sentinel data because you can study more the impact of the flood. And now the last is radiometric resolution. Radiometric resolution is that, uh, I mean, the values here, minimum and maximum values. So if it is 16-bit, means you multiply 2 times 2 times 2, how many times? 16 times. So minimum and maximum value will be there. Okay. If it is 8-bit, because earlier you see here Landsat 5, okay, Landsat, you see the 5 is 8-bit data. Okay, Landsat not 5, I think should take, or maybe Landsat, you see. So if this is 8-bit resolution, the minimum and maximum value will be 0 to 255. So which one is better, 16-bit or 8-bit? And 16-bit is better. It can discriminate more uh, from one feature to another feature. So this is what a radiometric resolution. So this was all about the chapter 2, and you can look at the different types of data. You can copy this link here and you can study and you can do some comparative analysis that which data has uh, what type of characteristics, which may be used further for uh, I mean, this is not only band, these are not only bands, but you can use 2 or 3 bands to develop some indexes like ndvi ndvi, which is used to study the vegetation. Higher ndvi means higher vegetation, low ndvi means below zero there is no vegetation, below zero means there is no vegetation, above zero is the vegetation. 0 to 0.2 may be some uh, dispersed vegetation, small, the I mean the vegetation plants may be here and there, smaller plants. So what is ndvi? And there are another indexes also, like if you are interested to see the water, then you can look at the Yes, here this is for open water because they are short wave infrared. So wherever the higher values will be there, there is a, you see, you will get the water, higher values, because this is down the lower values. Okay, this short wave infrared is being absorbed by the water, so it has the lower values, and these are the green is a higher values. So higher values divided by lower, you will get the higher values with the water areas. So it's good to study the vegetation and water. You can collect the time series data, and then you can look at the variations in vegetation and water in a time series, and you can report whether vegetation is increasing or water is increasing or decreasing. What is the impact? So all these things can be studied very well with the help of a remote sensing data. I hope you understood it. If there is any doubt, then we can discuss when we meet uh, in an online lecture. So thanks for watching this video. See you again.